Okay, let's get started. I hope everyone had a great weekend. Football team's finally coming back. It's been 6 or 7 years since I've been that excited about football. So it's nice to see a change in a trend from year to year. So today we're going to go over how to change permissions, actually give you notes on how to create a script, as well as how to do some more complex things in script. You kind of saw a couple of them last week. And then we're going to start going over Makefiles, which will be kind of where you're starting to venture into 240 topics, or you're going to start getting to the point where all the topics from now on will be covered, will help you directly in 240. So after today and maybe Wednesday, after we learn the basics of Makefiles, we're probably going to learn some C++ here and there, just so that you're familiar with some things. And then that way you can write a couple things, you can be a little bit familiar, you can compile it, you can run it, and so on. But for now, we're just going to learn the basics of Makefiles and what you need. I will say this is the part where I'm starting to get excited about the course, because we're no longer doing kind of mundane things. We're doing more exciting things, compiling, creating our own programs, scripting things that actually matter versus just learning the basics. So I think I'm more excited about the rest of the class. So a couple things about homework 1. The way I originally wanted to grade it doesn't seem to be valid to grade it. So as long as you submitted what I wanted in the form of a URL, so that means that your GitHub repository exists, the commands, as long as you gave me the commands that you used during your assignment, and then as long as you gave me a brief description, you'll probably get full credit for the homework. Homework 2 will be coming soon in the next week or so maybe this week or next. It will build upon the last homework, so you just set up GitHub in the lab's last homework. Now you're actually going to use GitHub and do some things with it, back up your stuff, write a couple things here and there, and whatnot. Midterm will be graded by November 2nd, which is last day to drop without getting a WF. So probably November, probably end of the month you'll have those grades back. So office hours today till 3:30 after the class, so come by if you want to. So quick overview. Today we're going to go over permissions, how to change your permissions for files, which gives you and other people access, also gives you more access to files. So up until now, we've really only had read and write permissions on files that we've used. We're going to learn how to change it so that we can run our scripts without having to do bash script.sh. We can just do /script.sh, and so on. So then we're going to do a couple more, go over some advanced topics in scripting, like using variables, functions, loops, conditional statements, arguments, and then Makefiles. So Makefiles, think of them as scripts for now. We'll get to them here soon. All right. So how do I know the current permissions of a file? So we've seen the command ls and its option L for long listing, and it gives you the permissions of files and directories. So if we actually go in here and I do, maybe go up a directory real quick, and I do ls-l, there's a section that's output that gives you the permissions. So you might not be able to see all of them on the projector, but if you can't see them, look at the screen. So you've got these 9 characters right here that are permissions, and they stand for read, write, and execute. So R for read, W for write, X for execute. And then you're like, okay, well, there's this D right here. So this D right here, all it stands for is if it's a directory or not. So in the case of all these are all directories. So all of these are directories. But if we go into maybe demo, and we do let's do touch test.txt, and then we do ls-l, then this D is no longer, this little character is no longer a D, it's just a dash. Yeah.
So what is the
So they're all one character. So these are RWX in this first three places, are read, write, execute. Then you have R-X, so you got read and execute for this person. We're gonna get there. And then same thing for here. But for now, all I want you to know for this slide is that you've got 9 characters right here that give permissions to you, other people, and everyone on Earth. And like I said, the leftmost character right here is for if it's a directory or not. That's all it does, that character right there. Okay, so back to the slides. So you have permission format of D, so 10 characters, and they're filled up with D on the leftmost, and then the right 9 characters are your permissions. Okay, so this is what those 9 slots stand for. So you got the D, what is it, a file type, a directory, file, whatever. And then the first 3, so the green first 3 characters are for you. So you, the user, this is your permissions. Then the cyan or blue 3 characters right here, the next 3 characters, are for everyone in the group. So we don't really go over groups in this class. Group is a networking concept to say, okay, this group of people has these permissions to do these things. So you don't really need to worry about that. And then red stands for everyone else. So this is everyone else is on Earth permissions. So this can be dangerous if you give everyone access to everything, like files, executing, reading, whatnot. So leftmost 3 characters, user, middle 3 characters is the group, and then the right 3 characters is everyone else in the world. And then you can see the other things that ls-l, what they stand for here as well. So again, read, write, execute. All right, so we need to go over a quick lesson on binary conversion. So, because you can do it other ways, but I find that the way of changing permissions with binary values is much simpler. So how do we convert from binary to decimal? So base 10. So base 10 is what you're used to. Binary is base 2. So how do we read binary? We go from right to left. So this first line right here, we've got 101, or 101, same thing other way, 111. And you read from right to left. So this is the 1's place, this is the 2's place, this is the 4th's place, then the 8th's place. You double it each time. Each bit that you go up to the left is double the previous. All right, so you have this binary string, so 101, and then you multiply it by powers of 2. So 1 times 2 to the 0 is 1, because 2 to the 0 is 1. And then 0 times whatever, so that's 0, so we don't worry about that bit. And then we do 1 times 2 to the 2, which is 4. So 1 times 4 is 4. And then we add all these together and we get 5, right? So you do the same thing over here. So in this case, we're only going to worry about 3-bit binary numbers. But if you had 111, then it equals to 7 in decimal. All right, so binary to decimal conversion. All right, so how do we use this with permissions? So permissions use, like I said, those first 3, middle 3, and end 3 triplets, and you use the binary number. So if you want the user to have all permissions, read, write, and execute, then you set 111 in those 3 spots for the user. And then so you have 7 here. Okay, well, if you don't want the group to have any access, no read, no write, no execute, then you just put 0, because you have 0, 0, 0. And then if you don't want anyone else in the world but you to have access, then you put 0 here too. So 700 correlates to you only have access. Only you. Only your user has access. All right. So how do we do it? So we have this command called chmod, and what it allows you to do is you pass in that string, so 700 or whatever binary permission value you have that's converted to decimal, and then you specify the file or directory that you want to change. And there are options like recursive change permissions, like I think it's -R or something for recursive change permission. So change the upper level and then go all the way down and change everything below it. But yeah, so chmod uses permissions. So what you do is if you want to do nothing, basically change it to where no one has access. Why you would ever use this, I don't know. Then you do chmod 000 the file or directory. Then no one has access. So it's basically like a dead file. I don't even know if it'll let you do this, actually. Let's say you want to give just the user. So the user, want to have all access, read, write, and execute. So you do 111.000.000, that equals 700. And then you do chmod 700 file. So this is pretty safe. Means that you have the power to do whatever you want. Obviously, if you don't want to have all the power, you can change it to just 600 or something. So that means you would change, so you don't have execute permissions, you change this to a 0. So then you've got 0, 1, or 0, 2, and 4. So 2 plus 4 is 6. So you have 600, and so on. So then you have this one where it's, okay, now you're giving access to your user and your group, which can be safe. And then the worst thing you could possibly ever do with any kind of sensitive information or homework or anything is do 777, because that gives everyone access. So your peer can be like, okay, I know where his file is, and then go find it and steal your work or cheat or whatnot. So this is very dangerous. So that means they can delete your work. That means that they can look at your work, they can execute it, whatever they want to do, they can do it. So don't ever, unless you have a really specific reason, do chmod 777 on any file or directory. So, okay, so that's permissions. All right, so scripting, we've already gone over it several times. We've wrote a couple scripts in class. They're very simple. Now we're going to start getting into more complex scripts, or as complex as they should be. So we do scripts. You create a file, then they're easy to make things automate and repeat. You create a file, you put the shebang, so bin bash is what you'll use. If you're on a Mac one day and you're not inside this class, then you'll use bin Z shell instead of bin bash, and etc. So there's a ton of different shells, and these are not the only two scripts or like things you can put here. You can put Python here if it's a Python file. Again, the shebang only is there to specify, hey, this is what program you should run this file with, or script with. So for the most part, you'll probably only ever use these two. So, okay. So variables, just like any other variables, you just do a variable name equals the value. It can be a string, it can be an integer, it can be a double, float, whatever. The output of a command, etc. You don't have to put a type here. Bash and many other scripting languages just interpret the type. So you just do variable name equals this. If you want to access what's stored in the variable, then you have to put a $sign in front of it. So if you want to do echo whatever the variable's value is, then you do $sign. Otherwise, if you don't do the $sign, if you just do echo var, then it just prints var. So if I do echo, so if I do var equals 1, and then I do echo var, it just prints var. But if I do echo $sign var, then it gives you 1. And this is the same thing with several predetermined values or variables. They're called environment variables. So you're like, okay, how do we know where ls program is, right? Like the ls program is somewhere in the file system, but how does it know? Well, it's because it's added in your path. So path, $sign path is an environment variable. You echo it, and this points to all the places that software can be found. And you can add to this and make it to where if you have your own custom software and you want to run it without having to point to the path every single time, you can put your path where the executable is and add it to the path, and then it automatically finds it for you. So if you want to do something like make it to where you don't have to do // in a few minutes, then to run a script, then you can add dot to your path. So the path always looks inside your current directory for an executable or for the program that you want to run. I'll show you that in a second. All right, so that's variables. You can do functions. So you do a func name, you put in the parameters, and then you put whatever commands inside. And sometimes you'll have to put semicolons here too. It might be good practice to just put semicolons. But otherwise it's kind of implied. You can use loops for while loops, for loops, if statements, etc., just like your typical programming language. But here's why you shouldn't, right? So there are 15 different ways of writing an if statement. So if we go to Google real quick, and if I say if statement bash, go to the first one, look through here. Okay, there's one with square brackets. Okay, well here now you have to remember -EQ, -GT, -LT, whatever. Not a fun syntax. Okay, so there's one syntax way of doing if statements with one square brackets. And then you're like, okay, well then why are these not inside of the brackets, right? You're used to different syntax and consistent syntax. If we go to a different one, it's probably going to have a different way of doing it because there are different types of if statements that use different things. So this one's kind of the same. Okay, this one doesn't even have brackets. But yeah, my point is you'll see some with 2 brackets, you'll see some with 1 bracket, you'll see different syntaxes all the time with bash scripting. And sometimes when you get to this point, you're like, why don't I just use a programming language? Because I don't want to learn every way to program an if statement in bash, when I could just learn one way and do it in a programming language like Java or C++ or even Python. So once you get to a certain complexity, like looping or if statements, I would say you should probably give up on bash scripting, unless you really need to do it. Like I said, it's possible, you can do it. I'm not gonna really push you to know these two throughout the semester, unless there's a specific use case for us to use them. All right, so arguments. So I said this would come back, and it has. So if we go back to earlier in the semester, we learned that you can access arguments inside of scripts by their index. So this is 0th index, you've got 1, you've got 2, and you've got 3. So inside of a script, if you want to access these arguments, then you just put a $sign in front of them, just like they're a variable, right? So the first one is $0. If you want to get the command name itself, you put that in your script. If you want to get this option right here, these options, you do $1, and so on. $2, $3, and so on. So if you want to access these arguments, or if you write your own script and want it to have arguments and access these arguments, then this is how you do it. You put 0, 1, 2 with $signs in front of them. All right? And just a quick reminder, arguments are separated by spaces. So there are some cases where maybe it won't necessarily require you to use spaces, but it's good convention and style to put spaces between your arguments. So it's consistent every time. All right, so again, argument indexing. So we have a script called robot.sh. Then we have, okay, we're gonna run this robot sh script, which the only line inside of it is echo robot says 1, 2, 3 with $signs. And then we say, okay, we run it with /robot.sh because it has execute permissions. And then you pass in beep, boop, bop, and then it just echoes that statement because it's accessed right here. All right. So before we get to aliases real quick, I'll show you this real quick. So say we create a script. So let's create robot.sh real quick. And then I put echo robot says, and then $1, $2, $3, so on. All right, so normally the way we would do this is bash robot.sh, robot.shell. So normally this is what we would do. But now that we know permissions, we can try to do it, just run the script directly. Oh, and I forgot my bin bash. So come on, y'all were supposed to catch that and correct me. Come on. Bash. All right. So if I try to run this with bash robot.sh, it'll work. But if we want to run it directly, we can. But we have to change its permissions first. So right now, it says permission denied. And the reason that is because if you look at the permissions, I have read and write permissions, but not execute permissions. So we got to change that. So we have to change mod 700. So the 700 gives me read, write, and execute, and no permissions to anyone else except for me. And then robot.sh. We do LSL again. You'll see that the read for the user or the group and the everyone else is gone. So no one else has any permissions now. But I have read, write, and execute. And notice that now our shell script is green. So this, in some cases, in some terminals, when you change something to an executable, it'll show up as a different color. So in this case, it's green on the Linux labs. So now if I do robot.sh, it will work. It lets me run it. But we want to enter some arguments, right, to make it say something. So go U of SC football. So we pass that in, and it prints it. It inserts those arguments where they're supposed to be. And this is shorter. Notice that /robot.sh is shorter than putting bash robot.sh. It's a lot fewer key presses. Now, if I do it, let's see if I do it, if it works. Robot.sh. So mine works, but that's because I've modified the path. So in your terminal, it probably won't work. If you do robot.sh without a / in front of it, then your terminal's like, where's this file? I don't know where it is. But if you want to give it the terminal like a way to infer where you're looking at, specifically the current directory, then we do export path. So we have to add the current directory to the path. Equals. Then we do, oh no, we'd have to just do path equals $path. So everything that path already has, and then a dot. You press enter, and that adds this current directory. So dot is your current directory to the path. So this way, you can just do robot.sh instead of having to do /. So now you're getting rid of bash and the space and dot and slash. So a lot simpler. All right. So yeah, so that's changing script permissions, running a script without having to do bash or /. Now we're going to do a couple more things to give you kind of some shortcuts. So a lot of people have said, oh, well, I don't like typing in tar-zcpf. Well, you can create an alias for this, which basically is a shorthand. So on my machines, I do alias LSA equals ls-a, and this way I don't have to do space dash. It's a lot easier to remember. So if I do LSA, it does the same thing that ls-a does. It's the exact same thing. If I do LSL, it does what ls-l does. And so on. And you can do any alias. So CLS on Windows is clear the terminal or whatever, just like clear is for Unix. So I mapped it. You can do any of this. So if I want to do alias, let's just do test 123 equals echo hello world. And then I do test 123. There we go. We just created our own little macro to help us do things faster. So you can do this with any command for the most part, and alias them. You can also alias things to function names if you want to run a function or something with an alias. You can do a lot with aliases to make your life simple. So y'all remember the .files directory that we created? I have my own on my GitHub. And in here, I have this Z-shell custom file. Here's all my aliases that I have. So I have one that prints the color, I have LSL, LSA, LSLD, whatever that does, I don't even remember, etc. I think it's for directories only. So ls show directories in long format, ls. We won't talk about that one. So yeah, I add a ton of different aliases. And eventually you probably will have some too. Maybe not this much, but yeah. And I've got some functions in here. So that brings us to our next point, is you can save your aliases. So if I exit, so remember I have test 123 right now. So if I have that now, but then I change a terminal or run bash, and I try to do test 123 again, it says command not found. That's because this alias is only for that current terminal. So it only exists or is defined in that current terminal. So you have to define it somewhere more permanent, which is your bash rc. So we go to vi.bashrc, and we're already in our home directory, but if you do this from anywhere, you can edit it. And it's got a bunch of stuff already in it. But you just scroll to the bottom, and you can add all your aliases here. You can also add the path thing, export path equals path, $path : in here, and that will make it persistent instead of every time you refresh your terminal, it erases it. So you can add it here. And we'll probably do some of this in lab this week, so you can get a hang of it, of editing these things and whatnot. So yeah, use aliases, make your life easier a little bit, so you don't have to type as much. The most useful one I use, CDD, right? So instead of doing CD space ... I just have CDD. Yeah.
If you accidentally, by mistake, alias the command into an existing command, if you alias echo to CD.
Yeah, it will override it.
It will override
and
it.
you have to be careful with this.
Does it not give you a warning at all?
Nope. It will use one or the other. One or the other will take precedence, and this can cause issues. So if you, for example, use Python, so Python, you type Python in here, so Python's apparently not installed or not in my path, but if you use the pre-installed version of Python and then or alias it in your bash RC, it can do some really funky stuff if you're not careful. So you have to be a little bit careful to make your own commands, make sure they don't exist first before you alias. So CDD doesn't exist, so use it, and etc. LSA I don't think exists either. So, all right, so this gets to what I was saying earlier. So we can also run our scripts with /, but you have to, in order to do this, you have to change their permissions first to let them be executable. So 700 read, write, execute, nothing for everyone else. And then if you want to get rid of this /, so you can just run the script by doing scriptname.sh or script.sh, test.sh, whatever, and you just copy and paste this and put this inside your bash RC. And it makes it to where you don't have to ever type bash ever again, unless you're refreshing your bash terminal, or it will make it to where you can not have to do the /. Okay. All right, now we're at Makefiles. So Makefiles are weird scripts. They have their own syntax to define them, but they're very convenient. I use them quite often to make things a little bit more, I don't know, easy to run at times. So the way Makefiles work is you have a file and you have a bunch of recipes, what are called recipes. And these recipes are defined by whatever you want the recipe name to be, and then a colon. From there, you hit enter on your keyboard and you hit a tab. And then you write your command or script or whatever program that you want to run. However, if this tab is not actually a tab character, you'll have issues. If this tab, if you've remapped in our vimrc, for example, remapped a tab to be 2 spaces or 4 spaces instead of a tab character or just a /t, then your Makefile won't work because Makefiles are very picky. They are very picky about their syntax and what's a tab, what's not a tab, etc. But they can make things very convenient. All right. So a couple important considerations before I show you a Makefile or show you what a Makefile does is the top recipe will always run first by default. So if you just run make, M-A-K-E, then it will run the top recipe. Again, they have their own syntax. We won't learn all of the syntax. We'll learn some of it. There's a ton of syntax involved with Makefiles, but you don't necessarily need to know all of them to create them. And then Makefiles are for compilation. So now you're getting to the point of where you're no longer going to click the run button ever again. You're going to create a Makefile and build your script and then run it in separate steps. All right, so again, if I haven't emphasized it enough, in your 240 class or C++, software engineering, whatever it's called nowadays, you will have to write Makefiles. This is a big one, right? So you have to be sure you know how to do this. And again, you don't necessarily have to know all the intricacies, but knowing some of them is nice. All right. All right, so let's make a quick Makefile. So I'm just going to go into my desktop, and I'm going to go into demo, and then I'm going to create a Makefile. So touch Makefile. To my knowledge, you always have to capitalize the M. You might not. It depends on, there's different versions of Make that might be picky or not picky. For the most part, I've seen it always capitalized in my career. I haven't really ever seen it lowercase m, but yeah. Anyway, it might matter, it might not, but from what I've seen, it's always been capitalized. All right, so let's edit our Makefile. And like I said, this is just like a fancy script that's very picky about its syntax. So just like earlier, we can define a variable. So hello. And then let's say we want to create a recipe. So some recipes, or targets as they're called, also is all and clean. And then let's just do another one called message. All right, so we've got 3 different recipes, all, message, and clean. And so if we say all, we can say, let's do echo all recipe running. And I'm going to do this kind of similar thing for all of them. All right. And then I'm going to change it to be the same for all of them, or different for all of them. And now we've written our Makefile. So if we run make, just M-A-K-E, then it runs the top one. And it tells you what command it's running. And then it runs it. So it says, okay, I'm going to run echo this. And then it says, okay, now this is the output of what it ran. Right? So how do we run the other recipes? Well, you have to specify them because they're not at the top. So you can do make all. It does the same thing. But if you want to do the other ones, then you have to specify which one you want to run. So make message, make clean, and so on. So it's like an if statement, right? It's like a case statement in a language. Yeah.
Can you go back to the file?
Yeah. So I'm going to modify it more too. All right. And just like we've learned in scripting, you can access variables by doing a $var. But notice that the Makefile is a little bit more picky, right? It only changes the first character's color when you put a $sign in it. So Makefiles, in order to access a variable, you have to put quotation or parentheses around it. So now, and I'm going to bring up two terminals real quick, and I'm going to have to log in real quick as well. New window, SSH. Duo. Okay, so if I go into the desktop and then demo, if I type make again, now it inserts hello in here, which is this variable. It also puts in even the quotation marks even. All right. And you can define more variables and access them this way, and etc. So let's do something a little bit more complex. So let's say we want to create a bunch of files. So touch test 1.10.txt. And then typically what your clean recipe does is it deletes everything or cleans up your environment. So rm-rf test star.txt. Or we could do, yeah, we would have to do star or 2 question marks or something. All right, so we do make. And notice that it did the ... or it actually printed the ... That's because Makefiles syntax is different from and ran differently from your bash scripts. Yeah.
So it has to be named Makefile.
Yes.
Is that exact?
Yeah. Yep. As far as I know, the capital does matter. I mean, let's try it real quick. So move Makefile to Makefile. So let's do it. Nope. So it doesn't matter. Caps doesn't matter. But it looks for a file named Makefile. That is required. But the capitalization doesn't look like it actually matters. Okay. So we'll do more complex things with this. We'll compile, build different software executables. We'll link them together. You'll see where eventually, in a week or so, you'll see where we'll actually start doing a little bit of C++. We'll compile it, and that way you can actually see why this is useful. Again, the Makefiles are just like if statements. You have a bunch of ifs, or recipes, and then whenever you specify that recipe, it runs it. And that's it. So, okay, so I think, let's see what else. So again, coming soon is C++ coding. So this course, to my knowledge, has never taught any C++, or it has very little. I'm going to teach you a little bit more so that you can get started on 240. That way next semester, those of you who are going into C++ or 240 will kind of have a head start. You'll use Makefiles. I'll show you how they work. I promise they're not that complex, but they just take a little bit of getting used to. And then we'll use scripts with our Makefiles and without Makefiles to make some things like testing your code and whatnot.